It will be uploaded a little bit later today. The Wi-Fi has been turned off at school, so I will make the video, go home, and upload it. Sorry for the delay. Hopefully it'll be up by 7 p.m. tonight. Now, here's how it's going to work today. I'm going to show you a question. You will pause, write down the question, try to solve it on your own, and then you will play and see how I solved it, and make sure that you were able to check your mistakes, or just simply check that you did it correctly. Okay, so let's get started. Okay, for the first question, we're going to talk about creating a reflected figure. And here you can see that I have already created a figure, or I have already placed the coordinates on the graph that I have here on the left. So I have these coordinates here. It's 3, 1, so it's 3, 1. I have 1, 2, which is 1 and 2. 1, 3, 1 and 3. And then 3, 4, 3 and 4. Remember, it's always horizontal first and then vertically. Okay? And I have that figure there. Now, I'll do my best without a ruler to connect the dots. Okay? I have that figure there. Now I want to make a reflected figure. I can reflect this figure underneath. I can reflect it completely perpendicular to the other corner, or I can reflect it over here to the other side as a mirror. Okay, so underneath, mirror, or right directly across. Simply by changing the first or the second coordinate, or both coordinates. Remember that we move horizontally first. So if I wanted to create a reflection right here, rather than moving towards the right, I want to move towards the left. So what I need to do is change the positive first coordinate to a negative, so I go the other way. But I still want to keep the same height. I still want to move up, so I keep the second one positive. So in order for myself to do that, I have to change these coordinates here. Please pause the video and create a reflection here, exactly the same as this one, by changing these coordinates. Which one would you change? Would you change the first one or the second one? Go ahead, pause the video and try it. Okay, if you said change the first one to a negative, the first coordinate to a negative, you are correct, because rather than going to the 3 this way, we're going to go to the 3 in this direction and then up 1. So like this. Okay? And then negative 1 and 2. Negative 1, 2. And then we have negative 1, 3. Right there. And then finally, negative 3, 4. Negative 3, 4. So it should look like this. Okay, now you can see that you have a perfect reflection. Okay, the smaller side is here, and then the larger side is here. It's almost like looking into a mirror. Now, if you wanted to do the opposite, you wanted to make it down here, which coordinate would you change? You would probably still keep the positives that you have right here, keep the positive, but rather than going up, you want to go down. So you want to go to the negatives. You want to go down. So you would keep these, but you would have to change these. I hope you understand. You would have to change these to the negatives. And if you want to make a reflection here, then not only do you have to go negative this way, you must also go negative in this direction, vertically. So they would both have to be negative. So this one would stay a negative, negative 3 there, but instead of going up 1, you would go down 1 to here. So this has to change to negative. And you would do the same with all the coordinates. And that is how to create a reflection in any corner. Moving on. Next, we have to find the area for these two figures that you see here. So look, finding the area. Okay? Here we have a parallelogram. And here we have a triangle. How would we find it? So please go ahead, pause the video now. Remember, you need the multi-step. You need to write your formula, replace the variables, compute, and then give me the actual area with units square. We will call these centimeters. Okay, these are all centimeter squares. Okay, they're all centimeters. Go ahead, pause it, and try both of them. Here I have placed the formula for both of them so that you guys can go ahead and use them. The formulas will be given to you in the test, but it's always good to know them, memorize them. Base times height, area equals base times height. So you have your base times your height, the height of it. Remember not to follow the length because this has been distorted. You want to go straight perpendicularly up. And here we have area equals half the base times height. This is only half of what this would be. If you can look at it carefully, it's the same shape if you were to cut it down the middle. So this is only half. So you half the base times the height. The height is right there, from there to there. That's the height. You see that? It's 2. And then the base is from there to there. Okay, go ahead and try them. Okay, let's check our work for the first one. We have area equals base times height. Area is, for the base, is 4. 1, 2, 3, 4. And my height is 3. 1, 2, 3. So 4 times 3 equals 12 centimeter square. Remember, it is square because we have 2 dimensions. It's only the area. Okay, let's try the triangle. Okay, so far all I've done is just replace the variables, and I have half base times height. Now I can take this line as my base. Let's see, 1, 2, 3, 4, 5, 6, 7. I have 7. 7 is an odd number. I'm going to get a decimal if I cut it in half. So it's not really a good idea to use the odd number as my base. Going vertically to that for the height, I have 1, 2. 1, 2 is an even number. That would be easier to cut in half. So remember, you only have to cut one of the variables in half. I'd rather cut this one in half. So as you can see, I have half the height. I'm going to cut the height instead of the base. So half of 2 times 7. And here I'm going to write area equals, what's half of 2? Well, half of 2 is 1 times 7. And therefore my area is 7 centimeters square. Okay, I hope you got that, boys and girls. You can choose whichever one you want to be your base. This could be your base or this could be your base. It does not matter which one it is as long as it makes it easier for you to half whichever number you'd like. I half the even number, as you can see right there. Okay, moving on. Okay, please take a look at this cube here on the right side and find the volume. Remember your formula for volume, replace the variables, compute, and give me the actual volume. Please remember to include unit. The unit we're going to use for this will be inches. I-N. Oh, that's really big. I-N. There we go. Okay, inches. We're going to use inches. So please go ahead and figure out what the volume would be for this. Remember that is volume equals length times width times height. Okay, pause the video please and try it. Okay, I think we're ready to solve this. Remember to count all the dimensions. You have looks like a length of 4, width of 4, and a height of 5. Okay, so you have 4 times 4 times 5. Let's replace those variables. Okay, so 4 times 4 equals 16. Times 5 is 80, or you could have also done 4 times 5 is 20. Times 4 is 80. Whichever one is easiest for you. So we have 80 inches cubed. Please, boys and girls, do not forget about the cube. That is extremely, extremely important. Units overall are very, very important. If you do not write the unit in the test, it will be graded wrong. Moving on. Okay, now we're going to look for the volume of a triangular prism. And let's write down the formula that we need for this. Don't forget that first you must find the area of the triangle and then multiply it, factor the height. Okay, let's go ahead and write down the formula. Okay, let's see if this formula makes sense to you. We have the volume, and we have to find first the area of the bottom. So I have half base times width. I didn't say height. You can say whatever you like, but I called it the width because to me this is how wide the triangle is, how the triangular prism. That's how wide it is. But you could call it height, if you like, because if you were to turn it over, that would be how tall the pyramid or triangle is. And then, because I called that width, maybe I'll call the next the length. This is how long it is. Or you could also say this is how long. Boys and girls, it doesn't really matter what letters you use, what you call it, as long as you take into account that you have 1 dimension, 2 dimensions, and 3 dimensions. And one of these dimensions has to be halved. Always remember that. So you could have said volume equals half base times height again, or volume equals half length times width times height. It does not matter. But now let's replace the variable. Volume equals half base, half of 11, times 3, which is my width there, times, remember after a parentheses means multiplication, times our height. We factor in our height. Okay, let's compute this. I'm going to insert one more step just to show what half of 11 is. And half of 11 is 5.5. Half 11, right here, we have to half the base, is 5.5 times 3, and then times the height, or the length that we have here. Okay, so 5.5 times 3 is 16.5 times the 5.5. And when we compute it, we have 16.5 times 5.5 equals 90.75. Do not forget this part, inches cubed. And that is our volume for this triangular prism. Okay, I hope you were able to follow every step. This is very, very important on the test. Okay, next. Okay, on the test you're going to get a question similar to this one where you are given the area. There's your area. And you're even given the volume. See, there's cubed. Volume equals 315 centimeters cubed. And your area. What we don't know is the height. We have the area. We don't know what we multiply the area into so that we could get the whole volume. But we can simply by using the formula. Okay, we have the formula volume equals length times width times height. Let's replace the variables that we do have. Do we have the volume? Yes, we do. So we must enter the volume. Volume is 315 equals. That's our volume. Don't forget, it's right there. Do we have the length or the width? Well, we don't have length or width. But length times width is area. Length times width is area. So what we can do is, next time perhaps, we could put this in a parenthesis like that so that we can show that these two variables can be simply represented by 1. Remember, 35 centimeter square is 2 dimensions. 1 dimension, 2 dimensions. So we can just simply write the area. So we have 35. And then we have times the height. We are searching for the height. When we have an equation like this, boys and girls, we have to use a couple of steps. One is called isolating the variable, so we must invert the operation. What I mean by that is we have to take this number over to the other side of the equation, over to this side, because we need to isolate this variable. Isolate it means leave it alone. So let's do that. If I'm going to isolate it and I'm going to bring this 35 to the other side of the equation, I must invert the operation. On this side, it's multiplication. So I have to do the opposite when I jump over the equation symbol. If it's multiplication on this side, it must become division on this side. Okay, go ahead and do that. Feel free to pause the video now and follow the rest of the steps. And then check your work. I will continue. So pause now if you'd like. But I have 315. Now it's going to be divided by 35. Because on this side, remember, it was multiplication. See, 35 times. So if I'm going to take it to this side, it has to do the opposite. Now it's division. 315 divided by 35 equals my height. Well, when I take 315 and divide it by 35, I get 9. So my height is 9. 9 what? 9 centimeters. So I'm going to write 9 centimeters. Do I write square or do I write cube? No, because this is simply 1 dimension. This is just the length. It's not an area, it's just one dimension.